Hi everyone, my name is Iris Kamener and I'm a Program Manager for Azure Data Explorer, also known as ADX. Today I'll be talking about the Azure Data Explorer Confidential Computing Solution. Azure Data Explorer is a high-performant, fully managed Azure service that allows customers to run analytics on really large volumes of data and is optimized for interactive ad hoc queries. Azure Data Explorer works best with time series data, such as monitoring data, logs, metrics, and telemetry streaming data. It supports structured data, semi-structured data, such as JSON, and unstructured text data, including full text index search. With Azure Data Explorer, users can analyze petabytes of information in just seconds. By analyzing structured, semi-structured, and unstructured data across time series and leveraging machine learning, ADX makes it really simple to extract key insights from your data. Built for real-time, the platform provides a great number of high-speed data ingestion options to stream in fast-flowing data with as little as a few seconds delay after ingestion. ADX ingests data in a distributed fashion and handles both streaming ingestion and bulk ingestion. ADX features an intuitive, simple, and logical querying language called Krystal Query Language, or in short KQL, that enables data engineers, data scientists, and even business analysts to perform big data analysis independently. There are today over 350,000 users querying data using KQL. Azure Data Explorer has been a key component in Microsoft's digital transformation and is largely adopted both internally in Microsoft and across many companies and independent software vendors, ISVs. Now that you have an overview of ADX, let's discuss how confidential computing adds value to our solution. Looking at existing encryption technologies found today in organizations, we see that most organizations are already encrypting their data at rest, encrypting their data stored on disk. We also see that most organizations are encrypting their data in transit, using popular protocols such as TLS. What is missing in most organizations is the encryption of data stored in the virtual machine's memory. Here is where Azure Confidential Computing comes to play. The ADX Confidential solution is based on the AMD EPYC SEV-SNP technologies. These technologies add an advanced level of security for virtualized environments. SEV stands for Secure Encrypted Virtualization. This technology encrypts all data found in the memory of the virtual machine when it is saved to disk or transmitted over a network. This helps protect the VM's data by preventing unauthorized access. SNP stands for Secure Nested Paging. This technology supports a hierarchical paging model that allows only the administrator of a virtual machine to access the memory of his virtual machine. This creates an isolated memory region within each virtual machine that is inaccessible to other virtual machines and the hypervisor administrator. The AMD EPYC processors also supports a secure boot process, which ensures that the system only boots from trusted software. The confidential computing solution for ADX, Azure Data Explorer, adds additional protection use cases. Let's review some key use cases. The first use case is protection from other malicious VMs hosted on the same machine. By isolating the memory of each VM on the host, the malicious virtual machine actor does not have access to the memories of the other VMs stored on the same host. A second use case is the virtual machine's protection from malicious behavior of a hypervisor administrator or even a cloud administrator. With confidential computing, these administrators don't have access to the memory of the virtual machines. This prevents attackers from accessing sensitive data or executing malicious code within the virtual machine. A third use case is about protection from physical attacks, meaning attacks from people that have physical access to the host machine. Here too, the VM's memory is encrypted, so a person with physical access to the machine is not able to read the memory of a virtual machine. In addition, confidential computing technology is required to meet different compliance requirements, such as those mandated by GDPR and HIPAA requirements. The ADX Confidential Computing solution is based on the AMD Azure Confidential SKU. The recommended SKU for Azure Data Explorer is the EC-ASV5 SKU family. To create a confidential Azure Data Explorer cluster, simply select an EC-ASV5 SKU during cluster creation. It is simple as that. In addition, if you wish to migrate an existing ADX cluster to a confidential SKU, all you need to do is to select a confidential computing SKU as the target SKU. There's no code changes that are required in order to support this migration. It is a lift and shift, simple migration experience. Most customers who adopt confidential computing SKUs will also encrypt their data using Customer Managed Keys, CMK key. In case the ECSV5 SKU family is selected, the CMK key will be used to encrypt the data of the storage, but also the data of the SSDs attached to the Linear disk. You can use either ARM or the Azure portal to deploy or migrate to a confidential computing cluster. So to which customers' verticals are we targeting the ADX confidential computing solution? The financial sector is the leading vertical, spearheading confidential computing adoption, and they have strict compliance regulations of how to store highly confidential data. But actually, any company that manages highly confidential data, such as government agencies or healthcare companies, will highly benefit from confidential computing technology. Now I will present a short demo on how to create an ADX confidential computing cluster using the portal. In the demo, I'll create an ADX confidential cluster with CMK encryption using user-assigned identity. In this demo, I will use the portal to first create a confidential computing ADX cluster. After, I will go and configure the cluster to use a CMK key for encryption. As a prerequisite, you first need to have or create a key vault and assign it a user-managed identity. Here you see that I have a key vault called Iris Confidential Key Vault. I have granted access to this key vault to a user-managed identity called Iris Confidential User Identity. Now let's go and create a confidential cluster. So first I need to select a resource group and give the cluster a name. I then need to go and select a region. Note that currently not all regions support confidential SKUs, so you would need to check in Azure Confidential Computing documentation to see the list of supported regions. In the demo, I will select East US, as I know that this region supports confidential SKUs. Next, I will go and select a confidential SKU for the cluster. I will open the SKU list page and select a confidential SKU. You can identify if a SKU is confidential by this lock icon presented next to the SKU name. I will now select a confidential SKU. And that's it. Now I can go, review, and create my cluster. Once the cluster has been created, I will go and open the encryption blade of the newly created confidential cluster. Here I will first enable the customer managed key. I will then go and select the key from the Azure key vault that I previously created. I will then select the key and apply. Now I will assign a user-managed identity to the cluster. I will select the user-managed identity that I've previously given access to the key vault. Now I will save. And that's it. Now I have a confidential ADX cluster that is using a CMK key to encrypt the cluster's data.